Hi, my name is Tom Lever. In this video, I would like to present how the run detector function within Little YOLO version 3 / darknet works. This is part 3 of Little YOLO version 3, how darknet and YOLO version 4 convolutional neural networks work. Proceeding, here is my simplified and commented version of run detector. In this method, we extract arguments in the program's input argument vector. We extract these arguments to strings. These strings are paths to coco.data, YOLO version 4.cfg, YOLO version 4.waits, and dog.jpg. We define thresh and we call test detector. I would like to end this video after setting up test detector. Required inclusions are find float arg, which looks for -thresh in the argument vector, and if found, returns the next argument as a float, or otherwise returns 0.25 as float thresh. And we're also including test detector, which we will be setting up and looking at later. Over here is our Little YOLO version 4 for viewers solution and the beginnings of function run detector. So let's just start copying. First, we define the C string data CFG as the fourth argument of main's argument vector. For reference, this is the second. Detector is the second because darknet.exe is the first. This is the third, and this is the fourth, with index of 3. All right. Then string CFG is the fourth argument. String waits is the CFG is the fifth argument with index of 4. String waits is the sixth argument with index of 5. And string file name is the seventh argument with index of 6. All right. So let's do a little testing here and output these strings, these path names, to some of our configuration and data files. So we need to allow testing data CFG waits and file name by including the standard IO library. And then we can use printf to output as string data CFG, and then we want to also output CFG, weights, and file name. Let's give that a shot. All right, here they are, and I believe they're correct. So I'm going to comment out that testing, and here's a minimization button that appears, and I'll also comment out the standard IO library inclusion. And let's say that we are defining paths to configuration and data files. Okay. Then let's define thresh. Thresh is a floating point number used as a threshold to determine whether a prediction has a sufficiently high objectness score to be counted as a detection. Thresh is first used in function YOLO detections. This function is employed to find the number of detections associated with one of 3 YOLO layers. So we're defining thresh as find float arg in the argument vector, and we're passing the argument count, which I believe is 7, the argument vector itself, thresh, and 0.25. We haven't yet defined find float arg c, or find float arg, excuse me, find float arg. So let's go to this method here, and in our solution, let's create it. So first, we create the header file, find float arg, and we need inclusion guards. So if not defined, find float arg, define find float arg, and if, and then we want a declaration for this function. So float find float arg, passing the argument count, a pointer to a buffer containing pointers to strings, and then we also have as input the argument against which to compare a given argument in the argument vector, and we're passing in also a default value in case this argument is not found in the argument vector. So that's the header file. I'm just going to copy this for the actual definition of the function. This is find float arg. Okay. So how does it work? For each argument in main's argument vector, if the present argument in main's argument vector is equivalent to string arg, for example, the string -thresh, then convert the argument immediately after the present argument to a floating point number and return that number. If no argument in main's argument vector was equivalent to string arg, then return the default floating point number def. For example, 0.25. Alright, so to make this work, we have to include the string library so we can use the string compare method between some argument in the argument vector and the base argument -thresh for which we're using find float arg. And we also need to include the standard library to allow conversion from a string to a floating point number. So that completes find float arg. Now let's include it in run detector. Alright, and let's do some testing here. Allow testing find float arg. We're also using standard input output and printf %f thresh. Should be 0.25. Let's give it a shot. 0. Interesting. I forgot to actually return the default value in find float arg. Let's try again. There it is. All right. What else can we do? Let's test argc. This is an integer. Should be 7, I think. Yes. All right. And let's also test argv. Printf. So we're iterating over the argument vector to print each argument. So for int I 0, I is less than argc plus I increment I, and let's just print out the string pointed to by the ith pointer in the buffer of pointers pointed to by argv. Okay, so yes, here's the executable as argument 0, 1, 2, 3, 4, 5, and 6. So they're all there. Okay, and let's change our properties to include thresh as an argument, and let's do 0.26. Let's see if this changes things. There we go. Well, it found them as arguments, but it didn't seem to change anything. Wonder what that's about. So, taking another peek at find_float_arg, we're iterating over argument 0 through not 6, but now 8 out of 9. So this is 9, minus 1 is 8, index is 7. Well, first, I'm going to comment out this testing, and then let's test this actual method. So how many arguments is it recognizing first? 9. Okay, that makes sense. And it's going from the executable to argument 7, which should be thresh. If string compare argument vector of I equals this C string, So here, let's print out these two strings. It seemed to print out first. but not the remaining. So does that mean, oh, okay. So this return def statement is actually within the for loop right now. So let's take it outside the for loop. See if this fixes things. Give that a shot. And I need to uncomment out my testing here. Specifically, I'm interested in thresh. And there's 0.26. Okay, we got it. So I'm going to comment out this inclusion for testing and comment out that testing line. And now let's move on to test detector, setting it up. All right, so first I'm going to write the actual call. And this is taking cocoa.data, YOLO version 4.cfg, YOLO version 4.waits, and dog.jpg, the paths specifically. And it's also taking thresh for comparing the objectness scores and determining detections. And I'm actually going to bring this out back up to one line. Right. So now let's add test detector. Add our inclusion guards. And here is test detector. Don't mind the main content. We're just looking at this function signature right now. And it returns nothing and takes cocoa.data, YOLO version 4.cfg, YOLO version 4.waits as now wait file, and it takes dog.jpg as file name and thresh. And we need data types here, string, 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 and float. And we need a definition now. So I'm just going to copy this first. And let us add a C++ file here called test detector. And let's say that we're testing it to say using test detector, just to make sure it's called. We need to include it here. think we're ready to go. Yep. So let's get rid of this testing of test detector. All right. Just to make sure, going back here, let's add some testing of thresh here. Allow testing find float arg. And it also takes standard input output. I'm going to put a breakpoint here just to see what happens. 0.25 right now. We're in release mode, so it didn't seem to heed that breakpoint. Let me add fresh 0.26 here. Okay, there it is. It's working over here in Little YOLO version 4. So I'm going to minimize that, and let's minimize but keep that to comment this guy out. And I'm going to end by resetting these arguments. Okay, great. So in this video, we've set up run detector to take from the program input vector for strings corresponding to configuration and data files. We've defined thresh, used as a threshold to determine whether a prediction has a sufficiently high objectness score to be counted as a detection, and we've set up the next method, test detector.